Assalamu alaikum everyone and welcome back to the channel. So this video is basically about the summer bridging course that one of my students sent me from her school. So here you will have two identities because this is just for form 2 to form 3. So you have two units, identities and also so it's just identity. It's okay. So they are basically doing the basics of the identities. That's the whole course about. And so we have two learning focuses. The first one is to see whether something is an identity or not. And the second one is actually using the identities that you might have learned before, the perfect squares ones, those kind of, and then trying to do the expansion, factorization, and all those stuff. So what is identity, first of all? Identity is basically just like when the twins are identical, what do you say about them? They look the same. The left and right are same, their up and down are same, everything is same, right? Same goes to the maths. When something is identity, they have to be same to each other. And we will use the symbol 3 equal sign here. That's what we call identical to. This one is just equal to. For equal to, you can swap things from left hand side to the right hand side. Like this thing can go there if it's an equal sign. But if the question already gave you the 3 triple equal sign, then you do not switch them. And that's already identity. And then for identity, that left hand side is totally equal to the right hand side. Okay, now that's good, right? Let's do the questions. So first of all, you need to check, determine means check, whether each of the following equations are identity or not. So how do I know if something is identity? As long as left hand side is equal to the right hand side, then it will be an identity. So I will take out the left hand side first. So because this one is already having the solutions, I'm not writing down. So this is your left side, right? You take it out, write the whole thing left hand side LHS. All right. Open up. How do I open up? So the things that's outside is given to everything inside. This goes here, this also goes here. So 2 times 4, you have 8, and there's an unknown x, so 8x. 2 times -3, you can click calculator, -6, and then plus 2 from outside. And this one is having x, but these two are not. So this cannot be calculated together with these. These are all the constants. Constants means without having any x, y, z, anything, any variables. So this is, you can calculate together. -6 plus 2. If you can't do it in heart, do it with calculator. So that's your left hand side. How about right hand side? Right hand side is 8x minus 4. Oh, look, they're totally the same, right? And if left hand side equals to right hand side, then we will say that whole equation is an identity. Same goes for the B part. So if you want to prove if it's identity or not, take out the left hand side first. Let's take it out. And then open up. The thing outside goes inside. Outside goes inside. So -2 times x, -2x, and then -2 times -3, you can click calculator, you will have +6. Now, why is it a positive, right? So do you still remember negative becomes positive, negatives becomes negative. Negative positive becomes also negative. But if it's positive, it becomes positive, stays positive. And if it's negative, it becomes positive. Hopefully you still remember these things. So if the symbols are same, it becomes positive. Same goes here. Negative becomes positive. So that's why it will be +6. And what's on the right hand side? -2x minus 6. Okay. Are they the same? -2x, both of them have it. But left hand side, we have a +6. And then on the right hand side, we have a -6. They are not same. It's one is positive, one is up, one is down. So no, they are not same. If they are not same, you use the sign unequal to. So since they are unequal, left hand side is unequal to right hand side, so this is not an identity. So next, the first exercise is to prove that these are identities. So basically the markers know that these are identities, but they just want you to do some steps and show them that it is identity. In the end, if you'd find out they are not identities, that means you did something wrong, because the question was proving that it is. Just like prove that you are a female. Like obviously, who doesn't know that your mother is a female? Like That's just a saying in Chinese. I don't know if there's this thing in English as well, but it's who cares. Anyways, let's get back to the question. If this is identity or not. So first of all, write left hand side. What is on our left hand side? 4x plus 1 minus 4. And then open up the bracket. Everything outside goes in. Everything outside goes in. 4 times x, 4x, 4 times 1, 4. And then minus 4. What can be calculated with each other? This one is having the unknown x, these two don't. So these can be done together. 4 minus 4 is 0. So it's just 4x. And then what's on our right hand side? 4x. Less good. So since both of them are just having 4x. So this means since left hand side is equals to right hand side, so that whole equation is an identity. If you're lazy and you don't want to write this whole thing, you can just write so. This means so. It is an identity. Easy? Let's do the B one. So very quick, write the left hand side first. Left hand side, we'll copy down everything. Open up the bracket. So how do we open up the bracket? The thing outside goes in. The thing outside goes in. So that 2x, no change. And then 2 times x, you will have 2x. 2 times 1, you can click calculator. That's just a P2 question. 2 times 1, just one of the 2's. So 2. And then what can be calculated with each other? These both have x, so they can be calculated with each other. So 2x plus 2x. 2 apples plus 2 apples. Yay, 4x. That 2 can't be, they are not like terms. And how about on the right hand side? It's already expanded. Expanded means there's no bracket. So are they same? So we say since left hand side is equals to right hand side, so it is an identity. Good. How about part C? That's so long. Oh, it's okay. We are here to learn, right? So because both of the side we have to expand now. Left hand side we have x minus 6, 3x minus 1. Open up the bracket because it's more than one thing, so you have to be very careful. This first one goes to both of them. This first one also goes to both of them. And then we can't leave the other one, so the second one goes to both of them. Second one goes to both of them. So the first one first. X times 3x. The number is just 3. Then we have 1x here, 1x there. So it will be x squared. And then x times negative 1. Negative x. And then negative 6 times 3x. So numbers with numbers first. Negative 6 times 3. Negative 18. And then there's an x. And then negative 6 times negative 1. Negative 6 times negative 1. You can click calculator or you can do in your heart. Negative negative becomes positive. 6 times 1, 6. So it's just plus 6. Okay. And the next step is to see if any of them are having like terms. These two, right? They both have x. The other things you can't change because none of the other things have the x squared. And then negative x minus 18. You get negative 19x. Good. That's your left hand side. How about right hand side? Right hand side we have 3 bracket 2 minus 6x plus x squared minus x. And then again open up the bracket. The first one, it goes to everything inside. 3 times 2 you get 6. 3 times negative 6x. So numbers first. 3 times negative 6. Negative 18 and then x there. And then 3 times x squared. So 3x squared. Don't forget the negative x outside. Alright, and then any like terms? Yes, these both. So copy it down. You have 6. Negative 18 minus 1. Negative 19. You're already down 18 steps and one more step down. So it will be 19 steps down. And then just put it in order so that it looks nicer. In order means the highest power unknown first. X squared and then single x and then no x. Are these two the same now? 3x squared, negative 19x, and then positive 6. Yes. So since they are same, let me just copy it down because I'm already lazy because I'm having iPad, right? So I can do this part. Since left hand side equals to right hand side, so it is an identity. Hopefully you know how to do it now. Let's continue. So what's on our left hand side? Now if you're very quick, you don't even have to copy everything down. You can just skip some steps and then do the questions. Open up. This goes here, this goes here. So you will have -3 times 6, -18x, -3 times 1, oops, -3. Any like terms? Like term is having same unknowns? Yes, these two. So 5 minus 18, you get -13. Don't forget the x. That's it. And then how about for your right hand side? Right hand side, copy it once first because there's a bracket, so you have to open up the bracket. And then when you open up the bracket, it gives the negative to both of them. So negative and positive becomes negative. So it's -13x and -3. Now this one does not have any symbol here, so that means it's positive. So negative, positive, negative, negative, positive, negative. Because there's no other number, so you don't have to change the numbers or the unknowns. So this is your left hand side, this is your right hand side. Are they the same? Yes, since they are the same, so it is called an identity. Easy peasy? That's good. This is where you have to prove that it is identity. That means you have to make sure it is an identity. Now, if you have these type of questions in the exam, the trick, because this one you have to open up the bracket for the right hand side as well, but this one don't, right? So make sure in the end your left hand side is same as your right hand side. If they are not same, they won't be identity. And the question was proving, so it has to be identity. For example, this one you have to prove that they are not identities. That means your left hand side cannot be equal to right hand side. Easy? So let's try. So again, you have to expand everything. Check your left hand side and also your right hand side. And in the end, you have to make sure that they are not the same. Open up the bracket first. This goes here, this goes here. This goes here, this goes here. So 8 times x, you have 8x. 8 times 4, you have 32. 2 times x, 2x. 2 times 1, 2. And then any like terms mean having the same unknowns. Yes, the x ones. And also just the constants. Constants means just the numbers without having any unknowns. So the x ones first. 8x plus 2x, you have 10x. And then 32 plus 2, you have 34. So also let's check the right hand side. You have open up the bracket. So let's just open up. This goes here, this goes here. 10 times x, you have 10x. 10 times 3, you have 30, and then minus 4. Any like terms? Like terms means having the same unknowns or either they are constants. So 30 minus 4, you have 26. So is your left hand side and the right hand side same? Since they are not same, so you will write it is not an identity. All right, so let me just write it a little nicer so that you don't get so confused. So it should be like this. Remember, you have to write, you can't say copy from the above. It is not an identity. Let's do this one as well. So your left hand side, what do you have? X plus 5 minus 2, x minus 5. And then how about your right hand side? Write it later maybe. Now for this bracket, there's nothing in front. So you just write it back without the bracket. And then the next one, you have -2. So that comes in, that comes in. -2 times x, you will have -2x. -2 times -5. Negative becomes positive. And then 2 times 5, 10. And then see if there's any like terms having the same unknowns. Or they will be constants. So x minus 2x. So 1 minus 2. You're one step up, but now you have to go two steps down. So where are you at? So it will be -x. And then 5 plus 10, 15. That's your left hand side. How about your right hand side? On your right hand side, you have 3 bracket x plus 3. Yeah, and then open up the bracket. This goes in, this goes in. 3 times x, you have 3x. 3 times 3, you have 9. Are they the same? No, since they are not the same, see this one in the end and this one in the end. Since they are not the same, it is not an identity. Good. Next, write your left hand side is negative x minus 11. Open up the bracket. This goes here, this goes here. Negative x times x. So there's 2 unknowns. If that's the case and they're multiplying, your powers add up. 1x here, 1x here. 1 plus 1, 2. Then negative x times negative 11. Negative becomes positive. So positive 11x. Now how about your right hand side? Let's copy it first because it's a long one. Then you have a lot of brackets here. So this first goes to here. It also goes here. And then we can't leave the second part. It goes here. It also goes here. So x times x for the purple one first. X times x, you have x squared. X times 6, you have 6x. And then 5 times x, you have 5x. And then 5 times 6, you have 30. And now, do they have any like terms? If they do, you can calculate them together. Okay? So, like terms mean anything that have the same unknowns here. Or, nothing else. So, just copy it now. X squared, 6 plus 5, 11x plus 30. So, is this part same as this part? Nope, they are not. So, what do we say? Since they are not the same, so they will not be equation. They will not be an identity. Good. Thank you. And how about this one? Is this the thing? So so again, let's do the left hand side. Equals to 3 minus x. 1 minus 5x. Open up the bracket. This goes here. This also goes here. This goes here. This also goes here. 3 times 1, you will have 3. 3 times negative 5x, so negative 15x. Negative x times 1, negative x. Negative. Next will be positive 5x squared. You have an x here, you have an x here, so it becomes x squared. And then is there any like terms? These two. So you deal with this. 3, negative 15 minus 1. If there's no number hidden, that means it's a 1. If there's no number shown, then it means it's a 1. So negative 15 minus 1, negative 16x plus 5x squared. I'm writing too big, right? It's okay. Like nobody cares. Okay, right hand side. Open up the brackets. I want you guys to stop the video and do on your own first. And then check whether you get it or not. So 5 times x squared, you have 5x squared. 5 times negative 3, negative 15. And then copy everything else down. Now, is this the same as the above one? No, it's not the same. So what do we say? Since left hand side is not equals to right hand side, so it is not an identity. Remember to write this sentence in the end. This contains 1 mark. Okay, so that's how you prove not identities. So you just have to show that they are not the same. Next example first. This time you're already given that they are identities, 3 equal sign. And if that is the case, that means everything on this side has to be same as everything on that side. So this is a very common type for DSC as well, not just your TSA or your school exams. This style you must know how to do it. So how we do is open up everything on the left hand side and also on the right hand side. It's already open up here, so no worries. But this side you have to open up. And then we compare the coefficients, or we say the like terms. What does that mean? After opening up, you will have to see what of these things have x and what of these things have the constants or like that. So let's do the first example together. So on your left hand side, you have this thing, right? So copy it down and then open up. This goes here, this goes here, this goes here, this goes here. So 2 times x, you have 2x, and then 2 times 5, you have 10. And then 3 times x, you have 3x, and then 3 times -1, you will have -3. Cool. And then since they both have the x's, so they can be calculated together. And it's because they are the constants, so they can be calculated together. That's how you opened up. So until here, I guess everyone is clear. And then since we know that they are identical to each other, so everything has to be in order. So everything that has x has to be same as this one. So this whole part here next to x has to be the same as the whole part next to the x here. So it's 5 here and it's a here. So you will write 5 equals to a. Similarly, the constants are same with each other. They both don't have any unknowns, so they have to be same. So we write 7 equals to b. Good? Now it sounds a little confusing, right? Let's do some exercises and then get to it. So this one, first of all, right hand side is already opened up, so you don't have to think about it. But left hand side you do. So left hand side, first of all, what do you have? You have x plus 1 bracket x minus 5. You have to open up this one. So the first part goes here. It also goes here. And the second part as well. This goes here. It also goes here. So x times x, you will have x squared. And then x times -5, you have -5x. And then 1 times x, x. And then 1 times -5, -5. And then is there any like terms? Yay, good. So you do it everything. X squared, -5 plus 1, you have -4. You're 5 steps down, now you're going 1 step up. So you're at -4. X minus 5. That's how you did for the left hand side. How about your right hand side? What do you have? For your right hand, we have to make sure everything is opened up. So x squared plus ax plus b. And then now from the question, we know that it's the 3 equal signs. So it's identical to each other. So everything has to be same. So because it has identity, so everything has to be same. So that means the things next to the x squared, they have to be totally the same. And then the things next to the x, they have to be totally the same. And then the things that have nothing, or what we call constants, have to be same as well. Okay, now for x squared, they're already the same. Both of them just have 1. How about x? This is the -4, this is a. They're not the same, right? So we have to make them the same. So we will have to say this left hand side equals to right hand side. So we write that -4 has to be equals to that positive a. We found the value of a. That's good. And then the constants. Did I copy something wrong? Yes, it's positive b there. So these have to be same with each other. So I will write -5 equals to b. If it's a positive in front, you don't have to write it. Now that was a little easy question. No, it's not, miss. The opening up is so hard. Yes, I agree. The expansion is the hardest part. Next, also your left hand side first of all. 2x plus 3 x minus 6, open up the bracket, the first It's okay. I don't want to torture your ears too much. So first one, 2x times x, you have 2x squared, and then 2x times -6, -12x, and 3 times x, you have positive 3x, 3 times -6, -18. And then are there any like terms? Yes, the middle one part. The middle part. -12 plus 3, you have -9x. You can click calculator. That's your left hand side. And how about your right hand side? Right hand side, you have ax squared plus bx plus c. And then we have to compare everything together. If you have highlighters, use that. If you don't, it's also okay. So let's do it. Everything next to x squared has to be same. Left hand side equals to right hand side. So left hand side we have 2, right hand side we have a. So it's done. Here as well, left hand side is -9, right hand side is b. So done. The -18 equals to c. That's how you get the 3 marks for the answers. And 1 mark for the step, 4 marks. Or some teachers, if they are nice, they may give you 5 marks for 1 question. That's too much. If I'm the teacher, just 3 marks. But I still need you to write the step. No steps, no mark. Yeah, that's me. So. Next. Left hand side, you have 3x plus 1, x plus 6. You have to open up everything. Now let's deal with this number 3 first because it's too much, right? So give this 3 to the first. You just have to give it to one of them. No need because it's all multiplied. So it will be 3x plus 3. Don't forget the bracket because you still have a thing out the back. And then again open up. The first goes there. It also goes there. And this goes here. This also goes there. So 3x times x, you have 3x squared. 3x times 6, you have 18x. And 3 times x, you have 3x. And 3 times 6, you have 18. Any like terms? Yep. So write that down. 18 plus 3, you have 21x. That's your left hand side. And what's on your right hand side? You have ax squared plus bx plus c. And then you have to compare and the constant. So we will know that 3 equals to a, 21 equals to b, and then 18 equals to c. You can always switch them. C equals to 18, b equals to 21, or a equals to 3. Up to you. You can write one more line. A equals to 3, b equals to 21. It's all have the same meaning. Okay, good. Then next one. Let's do a little quicker because I don't have much time left. I'm making this in the school and I'm soon off. Yeah, we have early leaves these days. Open up. The first one goes here. It also goes here. The second one goes here. It also goes here. So a times x, ax times x. So x times x first, you have x squared. So it will be ax squared. And then there's a negative abx. And then next 2 times x, you have 2x. 2 times negative b, negative 2b. You can't do anything else because there's so many unknowns. So just leave it there. How about right hand side? You will have negative 2x squared plus cx and then minus 6. Now why am I writing like this? Because I wanted to put everything of the x squared in front, everything related to x in the middle, and then the constants. And now I can compare them easily. So everything that have x squared, they are together. So a will equals to negative 2. And then from the middle, because they are all with the x, you don't have to write the x, just the things. So it will be negative ab plus 2 equals to c. And then the last part, negative 2b will equals to negative 6. The first one we already know is done, so a we already know. Here too many unknowns, so let's just leave it there. How about this one? Negative 2b equals to negative 6. Negative 2 here is multiplied. So if you go to the other side, it will be divided, and then you can click calculator. Negative cancel with each other. 6 divided by 2, 6 divided by 2, 3. So b is 3. We know a, we know b, and then do we know c? Let's just calculate. We know a, right? A is negative 2. We know b, right? B is 3. And the other things just copy it down. Now, when you replace something, it's better to give a bracket. It's easier to calculate that way. And then now you can click the whole thing in calculator, or you do it in your own. Negative becomes positive. So 2 times 3 is 6. 6 plus 2, you get 8. Good. Next, We already know that the followings are the identities, and we also see the triple equal sign, so we do it easily. A part first, left hand side, we know it is 2x plus 9, and the right hand side, we know it's bx plus 9, and since we know its identity, so this will equals to this. So 2 equals to b, or we could say b equals to 2. Same goes for the part b. Left hand side, we already know it's y squared minus ay plus b. How about right hand side? It's so complicated, but we are good with maths, right? So we can open up. Have you not, miss? It's okay. It takes time. So y times y, and then y times 2y. And then negative 3 times y, negative 3 times 2. So y times y, you will have y squared. Y times 2, you have 2y. Negative 3 times y, you have negative 3y. Negative 3 times 2, you have negative 6. And then any like terms having the same unknowns, yeah, so you deal with that if it's possible, since it's a number now, so you can. Easy. And then we compare the same unknowns from left hand side and right hand side. Y squared, both of them have it, so let's not deal with that. And then the y's, and then in the end the constants. So the y's first. From the left hand side, for the y's you have negative a, and then from the right hand side, the y's you have negative 1. There's no number, so it's 1. And this negative and this negative, so both on each side, it's already balanced. If it's already balanced, you can cancel out. So a equals to 1. How about the constants? From one side, left hand side, we have b, and then from right hand side, we have negative. Oops, it's done. So b is negative 6. Next, left hand side, you have x plus 1, x minus 5. Open up the bracket. This goes here, this goes here. This goes here, this goes here. So x times x, you have x squared. X times negative 5, you have negative 5x. And 1 times x, you have x. 1 times negative 5, negative 5. Remember to pause the video, deal with on your own first the whole part. Because even for this one, the last one, we did an example here. Not really an example. Is it the same questions? X plus 1, x plus, yeah, this number 8 is the same as this one, and then this number 7 is the same as this one, and even this number 6, x plus 1, x minus 5, is same as this one. And then, do I have to explain? No, of course no, you can just replay the video. These are all the same. I didn't notice it. But it's okay, right? Maybe these are your exam questions. I don't know too. Because usually teachers don't repeat the questions, so it's okay. Okay, then let's just move to the part B, learning focus. So you have two different types of identities here. We call them differences of two squares, and the other one is called the perfect square. So you have to recite them kind of. Like, I know that you can calculate on your own, but sometimes we don't really have time. You don't really have, time to deal with everything. So it's better that you do recite them. Okay? So, or maybe I can continue this in the next video, right? That will be better. So in this video, we are until the part A, learning focus. And then, so this page 4, 5, and 6, I will make it in next video. So till then, tata, bye-bye, see you. Yeah, so those were the first part of the identities. Thank you, Allah Hafiz. If you have any questions, just tell me in the comment section down below, or you can contact me through the Instagram or even the WhatsApp if you have it. Thank you.